Okay, today we're going to be learning about the restrictions on rational expressions. So let's just start with the reason why you have restrictions. I can do 0 divided by 4, and I know that 4 is bigger than 0, so 4 will go into 0 0 times. That's an understandable statement. But if I do 4 divided by 0, 0 is smaller than 4, so it will go into 4, but we don't have any concept of how many times that will happen. So since we can't make sense of that, we say that division by 0 is undefined. So when you put this into the calculator is actually going to give you an error. If you do 4 divided by 0, it's going to say error. You guys hate my cursive ease. Error. Okay. So when dealing with expressions and equations with variables in the denominator, we have to make sure that the value we plug in for x doesn't cause an error. Now, if we're using the calculator, we can put in something like 4 divided by x into y equals. When we go to the table, notice that we have an error right here at 0. That means that 4 over 0 can't be done. That's undefined. All other numbers that we plug in for x in this particular equation, 4 divided by x, will work. Now, so this is what you're going to look for on the calculator in the table. Notice here on the graph, though, we've got two pieces of the equation. This piece and this piece are not touching each other. That 0 where the error is on the x-axis is that line right there that's going in between them. Okay, that's what an error looks like, or a restriction, sorry, that's what a restriction looks like on the graph. Okay, so a restriction on the table says error. A restriction on the graph looks like two separate pieces divided by an imaginary line. So I'm going to erase this line right here so you can see it again. Okay? All right. So the whole point here is that the denominator cannot equal 0. It's not that x can never be 0, but the denominator cannot be 0. So let's see what that looks like in a couple situations. So first we had our 4 divided by x. We saw that x can't equal 0 in that situation. Oops, sorry. There we go. Because here's the equation, and the table tells us that there's an error there. Okay? All right, so let's try the equation 4 over x plus 1. All right, there's a couple ways you can do it. One, you can look at the calculator, which we will do here in a second, but I know that x cannot equal -1, and we're going to test it. If I plug in -1 plus 1, what do I get? 0. So there's a couple ways you can do this. You can use the calculator, or you can just take the denominator, x plus 1, set it equal to 0, and solve for the x. So we're going to subtract 1 from both sides. X equals -1. Okay? Let's go ahead and look at this on the calculator real quick and see what it looks like. All right, so here I have put the equation into y equals. Here we have an error at -1. Now notice what happened on the graph. We still have those two pieces, but that imaginary line that neither one of them is touching has moved over to -1. So there are a couple of ways we can do it. We can use the calculator, or we can solve for x. Okay, let's do one more. We've got let me change colors, 2x divided by 3. Now, Do I have a variable in my denominator? No, all I have is a 3 in the denominator. So here, there is no restriction because there's no variable in the denominator. So we always have to pay attention to whether or not we even need to worry about restrictions. But we always want to look at that at the beginning of the problem, not halfway through or at the end. Which brings us to another point. When do we look for the restrictions, and on what equation do we find the restrictions for? So you are always going to find your restrictions on the original problem before you simplify and solve. Now, it's okay for you to do your factoring before you find restrictions, because the factoring can put it in a form where it's easier to see, but don't start simplifying or canceling anything out before you actually state the restrictions. All right, we are going to do a couple examples and get some practice. Let's see, first one is, let's use green. First one, 6/8. Do I have any restrictions on this equation or on this expression? No, because I don't have any variable in the denominator. So no restrictions. Second example, wasn't that easy. 3xy over 9y. Okay, what variable do I have in my denominator? I have a y. Okay, so I am going to come over here and set my denominator equal to 0. I want to solve for y. I want to get it by itself, so divide both sides by 9. 0 divided by 9. Oops. 0, oh, dang it. Y equals 0. So what this tells me is that y equal to 0 will make my denominator equal to 0, so it can't equal 0. Because remember, the denominator cannot equal 0. Let's look at another example. 6a. Oh, you might be asking on number 2, why didn't we have a restriction on the x? Because the x is not in the denominator, so it doesn't matter. So number 3, 6a over 18a squared. The only variable I have in the denominator is an a. I'm going to come over here and set my denominator equal to 0. Divide both sides by 18. I get a squared equals 0, and the square root of 0 is 0. So a cannot equal 0. Okay, number 4. Eight ab over 4a squared b. Okay, what variables do I have in my denominator? I have an a and I have a b. Well, since the only thing that's happening here is multiplication, what do we multiply to get 0? We have to multiply by 0. So what that tells me is that the a cannot equal 0 and the b cannot equal 0. Now you may be asking, why didn't I go over here and in red set my denominator equal to 0? Well, we've got 2 variables here, so that would make it a little bit more confusing. But hopefully at this point you're noticing that whatever we multiply by 0 gives us 0. So a or b, neither one, can equal 0. Let's go to another one. X plus 1 over 3x plus 3. All right, now I can go ahead and factor out a GCF in the bottom. I see that I have a 3 in both terms, so this gives me x plus 1. Now, in my denominator, I have a 3, and I have an x plus 1. Well, the 3 does not have a variable with it, okay? But the x plus 1, the parentheses does. So I'm going to go over here, and solve this for 0. So we subtract 1 from both sides. So x equals -1. So that tells me that up here, x can't equal -1. Now let's test it. If I bring this down here and do 3, I plug in a -1 for the x plus 3. 3 times -1 is -3. -3 plus 3 does make 0. So -1 would make the denominator equal to 0. That is why it is a restriction. All right, let's do another one. All right, my denominator is 6x squared plus 3x. I'm going to go ahead and factor my GCF out of both the top and bottom. I've got a GCF of 4x on top, so that leaves me 2x minus 1. I've got a GCF of 3x on bottom. That leaves me a 2x minus 1 plus 1. All right, so here, if you notice, I have a 3x times a 2x plus 1. So I need to put both of those equal to 0. So 3x equals 0, divide both sides by 3, x can't equal 0. And I've got 2x plus 1 equals 0. Subtract 1 from both sides. I get 2x equals -1. Divide both sides by 2. X equals -1/2. So I have a second restriction of x can't equal -1/2. Well, let's try plugging this in to the original equation. So I'm going to take my denominator and do 6 times 0 squared plus 3 times 0. Sure enough, that's 0 plus 0, which equals 0. So I understand that x can't equal 0. Let's try the second one. 6 times, and instead of -1/2, I'm going to use -0.5 squared plus 3 times 0.5. This is 6 times 0.25, and 3 times 0.5 is 1.5. All right, I forgot to stick my negative in there. So that's a -1.5. So 6 times 0.25 is positive 1.5. Let me try that again. 6 times 0.25 is 1.5. Plus minus, I'm going to go ahead and make that a minus 1.5. And 1.5 minus 1.5 is 0. So both of these numbers are restrictions. Okay, so that's the other reason it's good to go ahead and factor or do your GCFs, because it breaks it apart and it's easier to see more than one restriction. Okay, we've got 2 more to do. All right, number 7, x squared plus 6x plus 9 over x squared minus 9. All right, again, I'm only going to worry about my denominator right now. I'm going to factor it. This is one of my special cases. I know that the square root of x squared is x and x. This sign is negative, so I get a positive and a minus, and the square root of 9 is 3 and 3. Okay, so I have an x plus 3 and an x minus 3. We're going to go ahead and just bring the numerator over so it doesn't look like a half problem. All right, so I'm going to take this factor and set it equal to 0, and this factor. So x plus 3 equals 0. Subtract 3 from both sides. X equals -3. So x can't equal -3. And then x minus 3 equals 0. Add 3 to both sides. X equals +3. So x also cannot equal +3. So let's test it. So I'm going to take my denominator But in place of the x, I am going to put a -3. -3 squared is +9, and +9 minus 9 is 0. Okay, so that's for the negative. Now I'm going to try it for the positive. +3 squared minus 9. +3 squared is 9, and 9 minus 9 is 0. So that one doesn't work either. Okay, one more. If I'm going too fast, you guys know you can pause at any point. All right, here's our problem. The denominator is 3x squared minus 8x plus 4. Okay, to find my restriction, I am going to factor the denominator, and I'm not going to spend the time going through that process. I would strongly recommend you hit pause, try factoring it yourself, and then turn it back on and see if you agree. So I'm getting 3x minus 2 times x minus 2 as my denominator. So I am going to look at this factor and this factor. So 3x minus 2 equals 0. Add 2 to both sides. I get 3x equals 2. Divide both sides by 3. I get x equals 2/3. So one of my restrictions is x can't equal 2/3. Then I am going to take my second factor. X minus 2 equals 0. Add 2 to both sides. X equals 2. So x cannot equal 2. All right, I'm going to leave that one for you to check. Make sure that plugging those in gives a complete denominator of 0. And that is how we find the restrictions and why we have to pay attention to them. If you have any questions, email me.